Lesson number 2, how to classify classification of set. So the first we discuss a finite and infinite set. So what is the definition of finite set and what is the definition of infinite set? Also we discuss what is the example of finite and infinite set. So finite, that means a set is said to be a finite if its element can be counted, and it is said to be infinite if it is not possible to count up to the last element. That means what? Suppose if we write 1, 2, 3 up to 100. So 1 to 100 we count, 1 to 1000 we count, 1 to 1 lakh we count. Okay, so all are the finite. As for example, suppose a student in your school, so we count, so all are finite. Another example, students in a college, student in a city, student in a country, student in the world, so all example are count. People in the world, again this is the count. Okay, so that means a finite set, that means its element can be counted, and if the element is not counted, that means we don't know what is the last element. As for example, we consider the natural number n. So in a natural number n, we don't know what is the last value. We start from 1, then 2, then 3, up to and so on. 1, 2, 3, 1, 2, 3, up to and so on. But what is the last value? We don't know. So the natural number, capital N, is a infinite set. So finite, that means we count, possibly count, and infinite, that means not possible to count up to the last element. As for example, let P and Q are two sets. P, X is a whole number, and Q, X is a teacher of your school. So obviously a whole number, we start from 0, then 1, up to and so on. So we don't know what is the last value because up to infinity. So whole number is a infinite, and the teacher of your school obviously finite. So therefore P is a infinite and Q is a finite. So first definition of finite and infinite set. So finite, again I repeat, finite, that means its element can be counted, and infinite, that means it is not possible to count up to the last element. Now next, null set, empty set. So what is the null set, empty set? So a set which has no element is said to be a null set, empty set, or void set, and it is denoted by phi. This is the symbol of phi, or this is also symbol of the null set, curly bracket, but there are no element. So again, a null set or empty set. So a set which has no element is said to be a null set or empty set or void set, and it is denoted by phi or curly bracket, but there are no element. As for example, consider the set capital A. X is a number which is greater than 7 and less than 5. X is a number which is greater than 7. So greater than 7, that means 8, 9, up to and so on. Less than 5, that means 1, 2, 3, 4. So there are no element which is greater than 7 and less than 5. Now another example, we consider x belongs to n, where x plus 4 is equal to 0. So x belongs to n, x plus 4 is equal to 0. That means we find the value for x is equal to minus 4. But x is equal to minus 4, which is not belongs to n. So therefore, the set A, there is no such number which is less than 5 and greater than 7 in the set A. And in the set B, there is again no natural number whose value is a minus 4. Because this equation is satisfied when x is equal to minus 4. Because here we write minus 4 plus 4 then 0. So minus 4 is not belongs to n. So again B is a null set and A is also a null set. Okay. So both are null set. Now next, singleton set. The word is a singleton. In a previous, the word is a null. Null, that means no element in the set. Empty, that means no element in the set. Singleton, that means a set which is involve only the one element. The proper definition, a set which has only one element is known as the singleton. So what is the definition of singleton set? A set which has only one element is known as a singleton set. How to define? What is the example? So suppose consider the set A. X is a number which is greater than 5 and less than 7. Greater than 5. So 6, 7, 8 up to and so on. Less than 7. So 1, 2, 3 up to 6. So the common is a 6. So therefore, as there is only one number 6, so the set A will have only one element. Such set is said to be a singleton. So we denote a capital A is a curly bracket only 6. So this one is a singleton set. Singleton, that means only one element. So again, the definition of the singleton set is a set which has only one element is known as the singleton. Now next, equal and equivalent set. So what is the difference between the equal and equivalent set? So now, first, we discuss the description of the equal and equivalent set. Suppose two set A and B are said to be an equivalent set if they have same number of the element, but they are said to be equal if they have not only the same number, here only the same number, but here not only the same number, element are also the same. So equivalence, that means there are two set is given, the number of the element of two set are equal, then we can say the equivalent set. But equal set, that means a number of element and the element are also same. So both set are equal set. As for example, equal set can be written A equal to B, and equivalent set can be written A equivalent to B. So this is the symbol of equivalent, and this is obviously we know the equal. So again I repeat, what is the equivalent set? Equivalent set, that means if the number of element of two set are same, so equivalent. And equal element also same, number as well as the element are also same, then equal. Consider the set A is a 1, 2, 3, B is a PQR, and C is a 1, 2, 3. So obviously A and B, the number of the set A and B number of element is a 3. Here also 3, here also 3. And C also 3. Okay. So A and B number of element, B and C number of element are equal. So A and B are equivalents. B and C are also equivalents, but A and C, the number of element as well as element are also same. So A and B are equivalent set, whereas A and C are equal set. So A and B or B and C are equivalents and A and C are equal set. Now next definition, next classification of the set is a disjoint set. Disjoint. So obviously the word is a disjoint, that means not a join. And so now what is the basic definition of the disjoint set? So two set are disjoint. Two set are disjoint if they do not have any common element. So obviously, suppose we consider the one set is a set of girls in your school, and the another set we consider the set of boys in your school. So both are totally different. So there are no common element. So both are disjoint. As for example, suppose A is a 1, 2, 3 and B is a 4, 5, 6. So A and B, there are no common elements. So we call both set are disjoint. So now we stop here. Thank you. Now in the next lecture, again some basic classification of set we discuss. So now we stop here. Thank you very much.